While doing an experiment, Tom drops a ball out of the window 2.3 meters above the ground. The instant he does this, he fires his starter's pistol. Jerry sees the ball hit the ground at the instant he hears the pistol shot. So it takes time for the pistol's sound to reach Jerry. The speed of the pistol's sound is 344 meters per second. It is constant, will not change. How long will it take for Tom's ball to reach the ground? All right, so let's start with the picture. I've got this window, and the window is 2.3 meters above the ground. And then I've got Jerry some distance away, and I'm trying to figure out what that distance is going to be eventually. But I'm looking for time for it to fall. Let's see, he says that he drops, so the initial velocity is equal to 0. The acceleration is going to be 9.80 meters per second squared going down. And then, of course, when that happens, I'm going to have this sound wave propagating towards Jerry, and that's going to be from the pistol. So from the, oops, that's not how you spell bang, from the starter's pistol. Okay, let's see what we're given. Givens. I know the initial velocity is equal to 0. I know the acceleration is negative 9.80. Well, we'll leave off the negative for the moment. 9.80 meters per second squared going down. I know the distance x naught, where I start in the window, that's going to be equal to 0. And x is going to be 2.3 meters from the window down to the ground. Let's see, anything else? No, that's it. And first question, how long did it take for Tom's ball to reach the ground? So I'm looking for time to begin with. So I need an equation with v, a, x, and t in it. v, a, x, and t in it. I'm looking for t. So that's going to be x equals x naught plus v naught t plus 1/2 a t squared. Now I can simplify this a little bit. Let's see. This, oh, that's not v. That's going to be v naught right there. It's almost a bad mistake. So let's see what goes to 0 real quick to get rid of some of these things. I know that x naught is going to go to 0. And I know that v naught is going to go to 0. So v naught times t is going to go to 0. And that's going to make my life a lot easier. X is equal to 1/2 a t squared. And I need to isolate t. Okay, this is going to be a lot easier. First thing I'm going to do is I'm going to multiply both sides by 2. So I'll multiply the right by 2 and the left by 2. That's going to give me, I'm going to move things around just a little bit on the other side. At squared is equal to 2x. Now I need to isolate t, so I'm going to divide both sides by a. So I'll divide the left by a and the right by a. On the left, you can see the a's go away. So that's t squared is equal to 2x over a. And finally, t is going to be the square root of 2x over a. And that's going to give us two roots, a positive and a negative. But time's only going to be positive, so the negative one's not going to mean anything to us. All right, so 2x. I'm also going to do something else. I'm going to assume, because all my arrows go down, I'm going to assume that this is the positive direction. So I'm going to use a positive x and a positive a. I could use a negative x and a negative a, and the negative divided by negative will give me a positive, and that's fine too. So let's see what this is going to be. 2 times x, 2 times 2.3 meters, divided by the acceleration due to gravity, 9.80 meters per second squared, because it's in free fall, so gravity's controlling it. And that'd be a square root. So when I do all that, I get that the time is 0.685 seconds. So that's the time. Next question was, how far away is Jerry standing? So for B, I'm looking for how far away. Ooh, that's really horrible. Okay, how far away? Well, it says that the speed of sound is 344 meters per second and it's constant. So if it's saying that it's constant, that's going to mean that the acceleration for the sound wave is going to be equal to 0. So that's nice, because I'm going to use this time again x is equal to x naught plus v naught t plus 1/2 at squared. So x naught's going to be 0. I'm solving for x. V naught is going to be the 344 meters per second, and a this time is 0, and that's because of up here. So x is equal to v naught times t. X is equal to 344 meters per second times the time I just calculated, 0.685 seconds. So Jerry is equal to 236 meters away. So the starter's pistol goes off. He sees the flash, but he doesn't see the ball hit the ground until he hears the sound of the pistol. And that's from those calculations, we can figure out the ball's in the air 0.685 seconds. And during that time, sound traveled 236 meters to Jerry's position. And then we know